It's something we all notice. You get a shiny new tool, and eventually it gets rusty. You buy the most advanced, high-tech piece of gear, and sooner or later, it wears out and fails. It feels like everything, from our phones to our cars, is just in this constant state of breaking down. Well, it's a universal problem, and today, we're going to pull back the curtain on the invisible war that's causing it all.
So this is the big question, right? We're not just talking about cheap stuff here. We're talking about advanced metal alloys, things that are engineered for incredible strength, like biomedical implants, and yet they all meet the same fate. What is this relentless force that breaks down even our very best materials? Well, it turns out the answer is much, much smaller than you'd think.
You see, the failure doesn't start with some big, dramatic crack. No, it begins with a silent battle. One that's fought on a scale so tiny we can't even see it. It's like this invisible war being waged on the very surface of what we think is perfect.
And that is the absolute key to all of this. This whole problem of things corroding and degrading, it all starts with these microscopic little flaws on the surface. Think of it like a tiny, tiny chink in a perfect suit of armor. It might seem like nothing, but it's the perfect way for the enemy to get in.
Okay, so let's zoom way in and meet the main bad guys in this invisible war. They're basically the microscopic assassins of material strength, and they have a name: micropits.
Now, a micropit is not just a little dent or a cosmetic blemish. No way. It is an active process. It's corrosion happening in real time. These tiny little cavities are like the beachheads in an invasion. They're the starting points where much bigger problems like rust, cracks, and total failure can begin to grow. They are literally the seeds of destruction.
And the way they form is so simple but so devastating. It all starts with a flaw that's already there, maybe a tiny imperfection from the manufacturing process. Then the environment, moisture, acid, whatever, it hones in on that one weak spot. The attack begins, a tiny pit is formed, and then that pit becomes the new weak spot for even more corrosion to happen. So if our surfaces are under this constant, invisible attack, how do we possibly fight back? Well, this is where science gets clever. Material scientists have basically developed their own form of high-tech armor, advanced surface coatings. Let's check out how we build our defenses.
The basic idea here is pretty simple. An uncoated surface is just out there. It's naked, it's exposed, and it's totally vulnerable to whatever the environment throws at it. But a coated surface, that has a shield. It's a protective barrier that stands between the material and all those corrosive forces trying to tear it down. It is the absolute first line of defense in this microscopic war.
But of course, not all armor is the same. One of these really high-tech shields is a nickel phosphorus coating, or NIP for short. Its structure is really cool. It's got this nodular shape. Just think of it like a surface made of microscopic cobblestones. And what's so brilliant about that is it spreads out any stress evenly. That design drastically reduces the number of weak spots where a crack or a pit could even start. And we can make this armor even smarter. Some recent research showed that if you add copper into that NiP mix, you get something amazing. The copper actually creates a self-lubricating layer when there's friction. So not only is this coating stopping corrosion, it's also actively fighting against being worn down by making itself slicker right when it needs to be. That is like armor that polishes itself in the middle of a battle.
Okay, but what happens when the enemy gets smarter too? What if it's not just a chemical attack anymore? What happens when you've got a two-pronged assault, both physical wear and chemical damage hitting at the same time? Well, that's when things get really tough for our high-tech armor.
And there's a name for this nasty combination: tribocorrosion. It's this terrible synergy where mechanical friction and chemical corrosion team up, and they don't just add their damage together. Oh no, they multiply it. The rubbing and scraping weakens the surface, which makes it way easier for the chemicals to attack, and the chemical attack weakens the material, which makes it easier for the rubbing to scrape more away. So here's how that destructive loop works. First, a little bit of friction scrapes off a tiny piece of that protective coating. Boom! Suddenly you have fresh, bare metal just sitting there, exposed to everything. That new spot corrodes super fast, which weakens it, making it even easier for the next bit of friction to do more damage. It just becomes this vicious cycle that chews through the material at an incredible speed. All right, so we've been deep down at the microscopic level. Let's zoom back out now and connect these invisible battles to the real world. Why does any of this tiny stuff actually matter?
This quote from some researchers really just nails it. The key word here is minute. It's the tiny, almost invisible defects, not the big, obvious cracks.
Those tiny little flaws are what really drive the whole process of failure, affecting not just how long something works, but even how it looks as it gets older.
And you can see the impact is huge, right across the board. For industrial machines, it means they just don't last as long, and repairs get expensive. For something like a medical implant, these tiny flaws can mess with its safety and reliability right there inside the human body. And for all our everyday stuff, it's that visual decay, the rust, the fading, the wear and tear that just makes things look old.
So at the end of the day, what we're really watching is this endless, high-stakes battle. On one side, you have our best, most clever material science, our smartest coatings and alloys. And on the other side, you just have the fundamental, relentless laws of chemistry and physics, which basically say that everything falls apart over time.
And that leaves us with a really fascinating thought to end on. We've gone from just watching things break to actually understanding this invisible war happening on their surfaces. We can now see the enemy. So maybe the next great frontier isn't just about building stronger armor, but about creating materials that can actually repair their own tiny wounds. What would a world built with self-healing stuff even look like? Definitely something to think about.